This is MCO455 week 10, and as we can see here, we have no chapter quiz this week. So what we're going to do is we're going to cover the specifics of Lab 6 and Lab 7, including the hardware that is needed. In Lab 6, we can see that we have to connect our 4-digit display to D2 on the Grove Shield. On page 58 of our textbook, we can see the layout of our Grove Shield here. And we can see that this is where we're going to be connecting up our 4-digit display. So far we've hooked up to A0, our temperature sensor, to A1, we've hooked up our pot, and for any one of these I2C connectors here, we plugged in our LCD. So what we're going to do right now, as I said, is connect up to D2, our 4-digit display. The Grove 4-digit display comes with a number of public member functions. Digit display allows us to specify the pin or pins that it's connected to, and we'll see that this is not only D2 but D3. On and off are fairly obvious. Set brightness allows us to change the brightness of our display by putting in a number from 0 to 7, where 7 is the brightest. We have set colon because we have a colon in the middle of the display, and we can either turn it on by set colon 1 or set colon 0 to shut it off. We can write 4-digit decimal numbers using the write function, and we can use write raw here to actually put patterns up on our 4-digit display. In Lab 6 in the procedure, we can click here to actually see the code, and you can see here that when we do digit display, and we could call it anything we like, we have to specify both D2 and D3 because both the yellow and the white wires on our cable are sending information to our 4-digit display. We've declared this to be segment, which is really referring to pin D2 and D3, and we set colon to 0 after we've cleared our display, so that means our colon is off. We've set brightness to 4, which is about a medium brightness. We've set up a counter here where we're counting from 999 to greater than 0 and subtracting 1. We're using segment.write to actually write those numbers from 9999 down to 0 and treating 0 as a special case because if you said greater than or equal to 0, then it would be an infinite loop. Once we do that, we're waiting for 1 complete second here, and then we're segment.write raw, so we're going to put a pattern. 6D is the pattern for S, 78 is T, 3F is O, and 73 is P. And then what we're doing here is we're setting up a loop here where we're actually using write raw now to go and look at the message array that we've got up here. And if we look up here, this is going to print out 4 blanks, then it's going to print out 3 blanks and part of this message where it's COVID. So the upshot of this is it's going to say stop COVID, and that's what it's going to do continuously here. The last part of Lab 6 deals with our passive infrared motion detector. Let's click here to take a look at the code. So let's take a look and see what's in our code here. First of all, our backlit LCD is set up here as flash, which is pins D14 and D15, which is any of those I2C connectors of the 4 that we have. We've got interrupt in with passive infrared. Passive infrared is going to be connected to D6 on our Grove Shield. And we're using that to set up an interrupt because as soon as the voltage changes on the passive infrared motion detector, that means it's detected motion, we should do something. Now we're using this global variable here, motion detected, and we set it to 0. And inside our interrupt service routine, when it's called up here, it's going to change motion detected from the default of 0 to 1 to indicate motion has been detected. Now, the way to set this up is we're going to say PIR because that is the pin we're using for our infrared motion detector. And it's going to then specify the address of this code. And that's the only way it's going to know where to go when the voltage changes on the passive infrared. Now, as we showed earlier, flash is actually dealing with our LCD, so we're clearing our LCD and we're setting RGB 0000FF, and this is a typo because it says set it to white, but if you remember, this is red, green, and blue. So it's going to be actually blue to start when you first start up, and then inside the loop it's not going to ever go back to blue again. But notice we got flash.clear here, which is going to clear our LCD, and then it's going to set it to FFFFFF, which means it's going to be white when we turn on all of the colors red, green, and blue, just like we did with our LED. Now it says if motion is detected. Now it's only going to detect motion if the passive infrared has been triggered and it's executed this code, then it's going to change this to 1. So there's nothing in this code in our main line that's going to change motion detected, so it has to go up here when it triggers from the passive infrared motion detector. So when it does, it's going to say, okay, right away, let's set motion detected back to 0, and then set this to FF0000, which means it's going to be red. It's going to wait a half a second, then it's going to go back and wait again for the next time motion has been detected. So every time motion has been detected, it's going to turn red. When motion has been detected, it's going to go back here and reset it back to white. Lab 7 deals with Bluetooth low energy, and we're using the Adafruit Bluefruit UART Friend to actually provide connection between your cell phone, whether it's an Android or an iPhone, to the microcontroller and running two different apps. One is called the Color Picker app and the other one is the Control Pad app, as we'll see. Now the details are given on page 74, but we're going to do it a little differently than is shown on page 74. On page 74, this is the most awkward way you can possibly make connections to your Bluefruit UART Friend. It shows both sides here, and this is not the way to do it. If you do it this way, even though it shows you where the connections are here, first thing you have to do is wrap the braided wire very tightly and put it in here, but you're going to have problems because if you don't solder it properly, one of these little vias here will pop off, and then it's not going to work, and you're going to have to order another one and pay shipping and handling on top. What came with your kit was there's your Bluefruit UART Friend, but it also comes with a little SIP header which has got 8 pins. And so what you're going to do is you take these shorter pins here and put them along here as shown here where the longer pins sit up. And then what you're going to do is you're going to turn it over, and if you got a piece of styrofoam, you can push it into this piece of styrofoam to hold it solid as you solder along the bottom here. And if you don't, you might have one of those sponges. I think there's sort of a yellow sponge that came with your soldering thing. You can push it into that, but whatever way you do it, make sure that you solder all of the bottom pins under here that are underneath. Once that's done, then what you can do is cut the cable that you've got here, one of those extra buckle cables, and then connect those connections to the top here. For instance, your ground wire here, you would actually make sure again that you twist that very tightly and then connect it to the ground pin that's here and solder it there. And so you make all the connections along the top here. Don't forget to solder the ground to the CTS here. And the other thing is make sure that this switch is pushed. And that's the easiest way to make it work. And then once you've done that, what you have to do afterwards is to plug the other end of this cable into the UART connection on your Grove Shield. Once you do that, everything should work. Now, when you first plug it in and you get power, you're going to see a red light come on indicating that there's power. And then when you run your Bluefruit UART Friend software for either the iPhone or the Android, you should see the blue light flashing when you've actually made connection.